Today we are going to learn about mastering Python control structures for AI efficiency. We will focus on using control structures to improve decision-making in AI models, teaching you to apply loops and conditionals effectively to optimize AI tasks.
Welcome to our tutorial on mastering Python control structures for AI efficiency. In this video, we will explore the fundamental building blocks that allow for the implementation of logic and decision-making in your AI models. Python control structures, such as loops and conditionals, are crucial for determining the flow of your programs and algorithms. They provide the means for executing code based on conditions, repeating tasks, and managing complex sequences of operations. By the end of this video, you will have a foundational understanding of how to use these structures to optimize your AI tasks. We'll cover if-else statements, loops, and delve into best practices to avoid common pitfalls. Let's begin our journey into efficient AI programming.
Control structures form the backbone of programming logic. In the context of AI, they are indispensable. Whether you're training a neural network, processing data, or implementing algorithms, control structures enable the program to make decisions based on data inputs and conditions. They help streamline processes by efficiently managing iterative tasks, such as looping through data sets or executing repeated operations. This is crucial in AI, where you often deal with large volumes of data and complex models. By using control structures wisely, you can enhance the performance of your AI models, ensuring they run efficiently and effectively. Control structures allow for optimization by reducing computational costs, improving runtime, and enhancing the scalability of AI solutions. In essence, mastering these structures is key to unlocking the potential of your AI applications.
If-else statements are the cornerstone of decision-making in programming. They allow your code to choose different paths of execution based on specific conditions. In Python, the syntax is straightforward. You write an if followed by a condition, and the code block that follows executes if the condition is true. You can add an else statement to specify what should happen if the condition is false. These structures are particularly important in AI for implementing logic that depends on varying scenarios, such as adjusting parameters based on input data or selecting different algorithms based on conditions. Nested if-else statements can be used for more complex decision trees, allowing for multi-level decision-making processes. By mastering if-else statements, you can create adaptable and intelligent AI systems that react dynamically to changing data inputs, ultimately improving the robustness and flexibility of your AI solutions.
For loops are a powerful tool for managing repetitive tasks, making them essential for AI programming. They allow you to iterate over sequences, such as lists, tuples, or arrays, executing a block of code repeatedly for each element. This is particularly useful in AI, where you often need to process large datasets or perform operations on neural network layers. For loops can help automate these processes, reducing the need for manual intervention and minimizing errors. Additionally, they enable you to apply consistent operations across data inputs, ensuring uniformity and reliability in your AI models. Optimizing for loops involves understanding the data structures you're working with and considering the computational cost of each iteration, which can lead to significant performance improvements in your AI applications.
While loops offer another method for executing repetitive tasks in programming, allowing code to run as long as a specified condition remains true. This type of loop is particularly useful in scenarios where the number of iterations isn't predetermined, such as training a model until it converges to an acceptable accuracy level. In AI, while loops can be used for tasks that require ongoing evaluation and adjustment, like dynamic parameter tuning or continuous data processing. However, it's essential to manage while loops carefully to avoid infinite loops, which can cause programs to run indefinitely and lead to performance issues. By setting clear exit conditions and employing best practices for loop management, you can harness the power of while loops to enhance the efficiency and adaptability of your AI models. Nested loops occur when one loop runs inside another loop, allowing for multi-dimensional iteration over data sets. They are particularly useful in AI for handling tasks that require processing data in layers or dimensions, such as image processing or multi-layer neural network operations. However, nested loops can significantly increase the complexity and computational cost of your program, so they must be used judiciously. It's crucial to understand when nested loops are necessary and how to optimize them to avoid performance bottlenecks. Techniques such as minimizing the number of iterations, using break statements, and leveraging built-in Python functions can help streamline nested operations. By mastering nested loops, you can tackle complex AI tasks with efficiency and precision.
Optimization is a critical aspect of programming, especially in AI, where the efficiency of your code can directly impact the performance of your models. Optimizing control structures involves making your code more efficient without sacrificing readability or maintainability. This can be achieved through various strategies, such as leveraging Python's built-in functions, which are often optimized for performance, and minimizing unnecessary computations within loops. Profiling tools can help identify bottlenecks in your code, allowing you to focus your optimization efforts where they will have the most significant impact. Debugging is equally important, as it ensures your code runs as expected, and any performance issues are resolved promptly. By adopting best practices in optimization, you can enhance the speed and efficiency of your AI applications, leading to faster deployment and more responsive systems.
As with any programming discipline, AI coding comes with its own set of challenges and potential pitfalls. Common mistakes include improperly managing control structures, leading to inefficient code or unintended behavior. To avoid these issues, it's essential to adhere to best practices, such as writing clear and concise code, using meaningful variable names, and commenting on your code to improve readability. Thorough testing and validation are crucial to ensure your code behaves as expected and produces accurate results. Additionally, AI is a rapidly evolving field, so continuous learning and improvement are vital for staying up to date with the latest advancements and techniques. By cultivating a mindset of ongoing education and adopting best practices, you can enhance your AI coding skills and contribute to the development of robust, efficient AI systems.
Thank you for joining us on this journey to mastering Python control structures for AI efficiency. We covered a broad range of topics, from the basics of if-else statements and loops to advanced concepts like nested loops and optimization strategies. Control structures are vital for implementing logic and decision-making in AI, and by understanding and applying these concepts, you can enhance the efficiency and performance of your AI models. Remember, practice is key to mastering these skills, so continue experimenting with different scenarios and applications. As you progress, consider exploring more advanced topics, such as parallel computing and machine learning frameworks. We encourage you to apply what you've learned in your projects and contribute to the ever-growing world of AI innovation. Thank you for watching, and happy coding!